Hello, viewer. Once again, this is Wattis. Deliverable 7 Automaton is his final report. I used Fusion 360 to design this model. Unfortunately, the computer crashed and I pretty much lost the whole design due to power surge. The gun can move up and down. The turret can traverse 360. The front two and the last two wheels are operated independently. The hatch in the back is for accessing the Arduino and the electronic inside. The ramp is where we can access the batteries and electronics inside the vehicle. That's the plan. However, COVID-19 appeared, so plan changed. Aside from the body, nothing else changed electronic wise. There are 6 LiDAR sensors located all around the vehicle to detect, locate near objects and obstacle. There is one sonic sensor to detect a pitfall. So let's see what this baby can do. Initial programming of the automaton, all LiDAR sensors are set to trigger course correction at limit of 100 or 10 centimeter. However, the drone hit the wall and takes some time to start course correction. The ultrasonic sensor for detecting the pitfall was set to trigger a reverse function if the distance is more than 50 or 5 centimeter. However, this condition turned automaton into a zombie or line following drone instead. This was predicted during the 3D design process. This was because of the downward angle position, which allowed the sound to bounce off the floor and away from the receiver more than into it. The solution was to increase the trigger range. The first correction at 200 or 20 centimeter for LiDAR and 100 or 10 centimeter for ultrasonic sensor. This, however, did not solve the problem, but chances of success of avoiding obstacle occurred more often. On the other hand, the ultrasonic sensor no longer triggered the reverse function anymore. Nor was it a zombie either. For the second correction, increase the trigger distance to 500 or 50 centimeter for LiDAR. No change on the ultrasonic sensor. The result was much more reliable. Even with 6 LiDAR sensors, the vehicle still have many blind spots. If the vehicle approaches an obstacle through these vectors, the collision can occur, as seen here. Nonetheless, I would call this attempt a success. I believe this is as much as we can get out of this design. This is the end of my first design and development of the automaton. There are a lot of lessons to be learned here from this project, in which I will have to chew on it for a while, perhaps write a full report for the future reference and self-improvement. I will have to redesign by incorporating a lesson learned to improve the performance. For example, replacing ultrasonic sensors with LiDAR sensors for pitfall detection. If I am to continue to use Arduino still, I will use 2 Arduino for project instead of 1. Perhaps Arduino Nano for movement and Uno for sensors reading, or simply depart from Arduino and use Raspberry Pi instead, or maybe both. In the future design, I will include camera for object detection and identification, which is what the modern self-driving cars are using. No matter what platform I am using now for learning and developing automaton, the next milestone for me will be when I shrink everything down into a single microchip or a single board. After all, I am a computer engineer. Making software into a hardware and shrinking things down are part of our job descriptions. This project is uploaded onto fritzing.org. Anyone wants to get the schematic codes and list of parts can download them there. I also leave the link here on the screen. It has been fun, even during the corona pandemic. It has reminded me why I want to be an engineer. Not the pandemic, of course. This is the conclusion of my project for EEL4935B Makecourse at University of South Florida. Thank you for watching. Good night and good luck.